But we're excited now to be able to showcase remote process control projects by our integrators. And so first up, we'll look at this project from SCS Engineers. And David, can you give us an overview of the project?
Sure, Don. So what I'm about to show you here is a typical example of what one of our cloud-based SCS RMC ignition systems looks like, particularly for a landfill gas blower flare station. Now, all of our systems are customized to fit our client's specific needs, but this is a pretty good generic example of what a landfill gas blower flare station could look like. We've implemented similar systems for pump stations, tanks, air compressors, weather stations, landfill gas to energy plants, air monitoring equipment, you name it. Basically anything that has a control panel or some sort of input or output, we can successfully integrate into this type of system. All right. So when our users first log into their system, they're presented with some sort of homepage. And what you'll see throughout this example here is that there's a couple main concepts that we're trying to implement throughout the system. The first is full-blown mobile functionality. So the system that you see here is accessible from a PC, like you're seeing here from the screenshots, and also from major mobile devices as well. So we designed around the Apple iPhone and Android device screen size, and that's why you see the column format for many of these screens here, that this is basically the same size as an Apple iPhone. So that's concept number one. Concept number two is that we wanted to design our system so that the most important information is very accessible and very visible and really will pop off the screen. The other information that the system is collecting is still available throughout the system, but you just got to kind of click into it. And this makes sure that the important information is very accessible and is very easy to see and understand. So for this example here, the important information that we're trying to impart to the user is that the statuses of the equipment. So we can see here that our flares are both on right now and all three of our blowers are on. If there was a problem, these would show up as alarms. And if we had an alarm, we would be able to go into the system and hit this reset button here, if appropriate, and restart the entire system. We find that many of our clients, this is the key button that they're hitting a lot, that their systems might go down from a power failure, or maybe their flare gets blown out, or whatever the case may be. And since this system is still, or is all mobile accessible, if it's the middle of the night, they can get their alarm, which comes to them through the ignition system, and they can figure out what's going on through their mobile device. They can look at the data and then identify if a mobile restart is appropriate. And if it is, they can just hit this button here, make sure that everything comes back up, and then go about their business. So another thing that we've implemented here is that we're basically, for these systems, the most important information is the well field vacuum and the total flow. So we've implemented some graphics here to help the users identify what's going on. So for the well field vacuum, we created this target looking thing that displays what the current well field vacuum is. And then it's also displayed as this black line. So as the well field vacuum decreases, the radius on the black line is going to decrease as well. And when it goes outside of this green annulus, the green annulus will turn to red, indicating that they are now in an alarm condition. When the well field vacuum goes up and it goes outside of the green annulus, it'll turn red as well, and an alarm would be sent out to the user. So they can really quickly identify what's going on with their well field vacuum. And then the same for the total flow, that we're displaying the breakdown of the flow between the two flares here. And the reason why this information is important to the users is that this really helps them to make sure that their systems are still in compliance. So it gets back to that environmental risk and environmental compliance concept that I was talking about before. Beyond that, a lot of our users are also really want to know how their system has been performing over time. So we've got a graph down here of the previous week's worth of information showing their daily total flow and their average vacuum. Now we added some additional functionality to this screen that shows, when you hover over top of the well field vacuum, you get this tooltip that shows you what the vacuum set point is and what the high and low well field vacuum alarm set points are as well. And then when you hover over top of the graph, you can see what the daily average vacuum was and what the daily total flow was. So this is that same screen, just shown in a mobile interface. So all of our screens will display well, just like this in a mobile interface, whether it's vertical or horizontal. Now, we looked at the home screen, and now we're starting to go through what we describe as the assets for the system. So for this system, they have 2 flares, and they also have a set of 3 blowers. So the 2 flare screens are fairly identical, and this is the screen for flare number 1. The key information for the flare systems are the flow, the well field vacuum, and the temperature. And we wanted to show these in ways that were eye-catching and really made the screen sort of pop. So we went with the concept that green is good, red is bad, and we're displaying the flow up here. Got the same well field vacuum target down here in the temperature. So just from looking at this at a real quick glance, we can identify that everything is fine and that our system is in good operation. Similarly, we have a graph of the flare flow and well field vacuum over here on the right, and the flare flow and temperature. So the users can look at these graphs and change the time frame on them to help them identify how the system has been performing over time. We also have controls that are built into the system as well. And one of the other key concepts with mobile functionality with this is that we went with large control buttons so that the system is very accessible in the field, that when you're out there and you've got gloves on and you can still hit that controls button and you're not going to accidentally hit the other data button or something else. So when you select the controls button, we have this pop-up that pops up, and this pop-up was designed again to fit on a mobile interface. So through the pop-up, the users have the ability to start and stop the flare, change whether it's in local mode, off, remote, or auto. They can go in and they can change some of their set points. Then they can change which one of the thermocouples are active as well. Another one of the key concepts for really all of our remote monitoring controls systems is that we want to give users the ability to remotely control the system, but only to the point where it makes sense. We don't want to give them the capability of doing something that would either be hurtful or harmful to themselves or to the environment or to the equipment. So in this case, in this example, we left off controls for things like setting up the sensors for the system. We don't really want them to respan the system or respan the sensors remotely, because that's something that would have to really be done there in person when you're installing the equipment. And similarly, we also didn't give them the ability to tune the PID loop set points, because that's, again, not something that you really do remotely. It's something that's done in person. Another example of this is that we have user access controls set up on our system as well. So if the user, like myself in this example, doesn't have the ability to write to anything, all of these set points are grayed out. So I can't go in here and change what the flow control valve set point is. And similarly, if I were to come down here and try to click on one of the thermocouples, I would be, to change which thermocouple is active, I'd be presented with this pop-up that tells me that I don't have the permission to be able to do that. Along the same lines, for users who do have the capability of controlling the system, they get a similar pop-up when they try to change something that asks them, are they sure if they want to do this or not? And it just adds another layer of security to this, that if you're out there and you're just trying to pan through the system and you accidentally click on something that you didn't mean to click on, it gives you the capability of saying, no, I really didn't mean to do that, and I'll just want it to operate how it's currently operating. Now, I was talking earlier about how we wanted to have the most key information shown, but still have the other information available. So to do that, we added this other data button up here on the screen. And through this button, the users are able to see the other information from the system. So they can see valve statuses, they can see whether equipment's turned on or turned off, and other miscellaneous temperatures as well. So the Flare 2 screen looks very identical to the Flare 1 screen. The only thing that we're showing here is that we have the same tooltip that pops up on the well field vacuum target, as well as what we were showing on the home screen. The blowers continue the same theme, that we're displaying everything in a mobile-ready interface. And for the blower system, we are concerned with the total flow, the well field vacuum, and then the breakdown between the two blowers. So again, we're trying to display that in a way that adds information to the user and makes it very eye-catching. Up here at the top, we have a settings button, and when the users select that, they are able to change set points for the way that the entire system is operating up here at the top. And then they have the capabilities of changing settings, or really controlling each individual blower. So they can go down here and they can turn the blower off or put it in auto, and they can also reset the runtime. Using these navigation buttons down here at the bottom of the screen, they can either click on those and switch between the individual blowers, or if they're on a mobile device, they can swipe and go back and forth between the various blowers. Similar to the flare screens, we've got our other data, and we're showing this for the individual blowers, and the users can pan between the different screens, similar to the previous screen. Now, we've talked currently about kind of the way that you can act on the instantaneous data and control the system remotely. Some of the other unique things that we build into the system is really having the ability to analyze what's going on. And that's what the next 3 screens are going to talk about here. So the first is a graphing utility that allows the users to be able to go in and remotely view how the system has been performing historically. So they can select whatever data points they want, and we've added in every data point that the system is recording, and then they can select what time frame it is that they want, and basically hit the add tags button down there, and we'll add the information into the graph over here. We found that this is a feature that a lot of our engineers and operators really like, because they can use it for a lot of different purposes. They can use it for troubleshooting, they can use it for reporting purposes. It's really a great catch-all tool that anything that's not displayed on any of the other screens, they can really dive deep into it here and get the most out of the system. Similar to the graphing screen, we have a data query screen that's got the same menu structure, the same date query part, but instead of displaying the data in a graph, it displays it in a table. So here I've selected temperature and flow from flare 1 and the wellfield vacuum for the entire system, selected a date range, and it displays it here in a table. The users can also download the data for further analysis or for use in reporting by clicking on that button, and it's saved as a file under their computer. Now, the final screen, and I think what might be the most, give you the most bang for your buck really out of all of these screens, is the alarm analysis dashboard. And we found that this is a tool that, again, our engineers, operators, managers really like, because it really enables them to get the most out of the system and really gives them the ability to intelligently direct their field resources. So we all have a limited amount of times that we can spend on doing things. And just for the sake of argument, let's say that a technician has an hour that he can spend out in the field troubleshooting in something with his flare station. So what he can do is he can pop open this interface. He can do it on his phone. He can do it from his computer. He can look at maybe the previous week's worth of data, and then it will show him how his system has been functioning over time. So it breaks down all the alarms that have happened over the time period that he selected, and it shows him the most important ones from a frequency standpoint and from a duration standpoint. So this one tells us basically the quantity of times that these things have occurred, and this one says how long have these alarms occurred over that time period. So from looking at this, we can see that the flare 2 low temperature alarm has been the most frequent alarm, and it's also been the one that was active for the longest period of time. So if that technician only has an hour to be troubleshooting something, he is going to be going out there and looking at this flare 2 alarm, not one of these other ones, because this one seems to be the one that is causing the most problems. So he can go out there and he can look at what's going on with his louvers. Maybe he needs to tune his louvers or tune his PID loop or something like that. So it really kind of gets back to what I was talking about before, that we try to listen to our clients' needs, and we try to give them technology tools that really help our clients to work smarter rather than harder, and really make very smart decisions. And it's, in this case, really centered around our SCS RMC ignition platform. So that's all that I've got. Feel free to reach out to me if you've got any questions or comments.
Thanks, Dave.